Hey everybody, I'm back, and in that last video I was talking about listening, and you could reasonably say it was just a gratuitous uh, sneaking in of some of my favorite composers into this day of sort of learning how to program. But I would say that the reason I did that is because I think that code is all about listening. It's all about constructing systems that listen. And we can take a look at some code that I wrote for you for today. You can see each one of these is something called an event listener. It waits for a button to be pressed, and then it does something. That is something that just listens. I would even make the case that these if-then statements are essentially listeners. They're waiting for this value to change, and they're waiting forever because they're inside this function that is a loop that runs forever. And computers are basically systems of switches that are set up logically in systems that respond to what was before them to create really complex interactions. And there's a really wonderful evocation or version of this in this book called The Three Body Problem that I finally read this summer. It's so good. I really like it. I recommend it. It's not very hopeful, but it is really great. And in this book, a couple of, I think it's Newton and I don't know, I forget exactly which mathematicians set up this. They get Aristotle, Mozzi, and Newton. They try to understand a really complex nature of reality by getting all these soldiers to hold up flags and to make this kind of version of a computer. It's basically what computers are, is they're really complex systems of switches that are created using this semiconductive material, and this semiconductive material allows these switches to switch on and off really fast. And they're usually set up in bytes. This is a little thing I made this summer just for fun, for you guys really, and for other students of mine, that shows how, here we've got 3 bytes, which each one has 8 bits. And with those 3 bytes, we can create a hexadecimal color scheme. If you want to understand how this works, I'll just run through it super fast. Computers are set up in base 2. What is base 2? On, off, on, off. When we set up these switches as on-off values, we can create in 8 bits. With 8 switches, we can make 256 possible values. In other words, 0 through 255. We do that by assigning a different value to each one of those switches. And we do the same thing really in base 10, which you're so used to, where we assign a different value to this row. So that's going to be the ones, that'll be the tens, there's the hundreds, the thousands, and so on. It's just like our base 10 counting, except it's just these on-off values. If that doesn't make a ton of sense right now, this probably is not the place to belabor that point, because I want to move relatively quickly. But you can see how if I set up this system of switches, here's 255 values, here's 255 values, and here could be 255 values, but it's set to 0. So what do I get? I get a red value of 255, which is fully red. FF. I get greens to 0 and blues to 0. Now we can see that actually in some JavaScript. There's a red right there. Light.setPixelColor number 9 to 0x, which says this is going to be a hexadecimal color, FF0000. FF being 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we can't use 10 because this is a 16 base number, right? So we're gonna say 9, and then for 10 we say A, B, C, D, E, and F. So this is 16, 16, 0, 0, 0, 0. 16, 16, 0, 0, 0, 0. And that's the same thing as this binary number 1, 1, 1, 1, 1, 1, 8 ones. And the same thing as in base 10, 255. Now, we use these colors. You can usually specify colors in JavaScript. In most programming languages, you can specify colors either as RGB in base 10 or as these hexadecimal colors. And we'll do it in both ways. You can do it in both ways. Just kind of maybe hopefully an interesting aside. And another interesting aside is that's also how characters are made on the page. So there's an I. I in an ASCII table has this value of 124 or 7C or 011111100. Because remember, all these numbers, all these letters, all these colors in a computer are at their base something like this. Collections of this. Is it on or is it off? They're just switches. And so in the next video, we're going to actually get into those switches. We're going to make some switches, and we're going to look at them and how we can write them in both blocks and in JavaScript. And we'll look at how we can write these event listeners as well. But before I go there, I want to just say one more sort of general thing, which is, you see these dots? These are collections. They're objects. They're classes. And these objects, right, this input you can see is here. So everything inputty is here. And all of these different methods, these functions, these values are associated with this thing called input. They're grouped together. This is object-oriented programming, and it's a big thing. It's a big, big, big topic that we'll come back to. It's an idea that was actually invented with this language called Smalltalk. This is slightly a historical aside, but it's also one that I think is kind of interesting. You'll hear about object-oriented programming. Those of you who are comp sci people, you've heard a lot about it already. Object-oriented programming was really cool. It was really cool when it was invented in the 60s, I think. And the reason it was really cool is, I guess, the 70s. Although I think Alan Kay was actually working on it in the 60s. It was really cool because it was based on messaging. And that's really all I have to say about that for right now. Is to say that object-oriented programming was based on messaging. Smalltalk, that's this programming language, which was the first object-oriented programming language. There are only objects. The language is the language of messages between objects. Messages between objects. Object-oriented programming, as some of you experienced it with Java and plenty of other programming languages later on, wasn't that. It isn't that. Object-oriented programming, as it became to be, is a hierarchical soup of bad ideas. It involves a lot of inheritance. It's not what we want to do when we program. And I just want to say that right off the bat, that when we program, and particularly when we program in JavaScript and other functional-ish programming languages, what we want to do is emphasize messaging. What we want to do is emphasize rhizomatic structures. What we want to do is emphasize small little bits that talk to each other. So I just wanted to say that right from the start. And I also wanted to just say the reason I got interested in Smalltalk was actually because I was interested in Super Collider, which is my favorite audio programming language, and I put a link to this on the syllabus as well. Check it out if you get a chance. It's really, really fun to play with, and a beautiful and very powerful programming language and IDE environment. And it's open source and free. All right, in the next video, we're gonna stop being so theoretical and get down to programming some stuff. I'll see you there.